So you can use derivatives to find the maximum or minimum value of a formula. So we use optimization problems involve finding the maximum or minimum values. So for example, a salesperson wants to maximize their profit. So on your screen you can see our first example. The cost per hour of a bike ride is given by the formula where X is the distance traveled. Find the distance that gives the minimum cost. So we use the same thing that we always do with these type of questions. We write out the formula first. Now, because we're trying to find minimum costs or a maximum, in this case minimum, we will differentiate it. And at this point, we want to find our stationary points. So remember, your stationary points are in that differentiation. The first derivative is equal to 0. So knowing that, we can say that 2x minus 15 equals 0. And then we rearrange it to find what our x is. So we get x equals 7.5. So at this stage we want to test what type of stationary point this is. So we find our second derivative. So our second derivative ends up being 2. And since our second derivative is greater than 0, we have a minimum. So what this means, alright, this means that 7.5, because it's in kilometers, is the minimum distance needed. And that's all there is to these type of questions. Alright, so you have a problem, we want to find the minimum cost and the distance required to reach that minimum cost. So we differentiate it, we find the stationary points, we determine the nature of that stationary point, in this case it was a minimum, and then you write a concluding statement. In our case, this means that 7.5 kilometers is the minimum distance required, alright, to give the minimum cost. Alright, so the difference of two numbers is 5. Find these numbers if their product is to be a minimum. Alright, so to begin with, we have a difference of two numbers and it's 5. So we can say that 5 equals some number x minus some number y. Now we want to find their product, so the product is multiplication, so it'll be x times y. Alright, and because we've got multiple things going on, I'm going to label 1 and 2. So I want to rearrange equation 1 to try and get something I can substitute in, because we're doing simultaneous equations at this point. And at this point I want to rearrange to get y as the subject. So what I can do is plus the y over and then minus the 5, and I end up with y equals x minus 5, which can be number 3. At this point we can substitute 3 into 2. So what I get here is I get p is going to equal x and then x minus 5. I can expand this out. So p is going to equal x squared minus 5x, and now I can start to look at differentiating it. So if I differentiate this, I get 2x minus 5, and as with all these problems, we know that this first derivative, if it equals 0, we have a stationary point, which is what we're trying to find. So I get 2x minus 5 equals 0. Let's rearrange it. So plus 5, we get 2x equals 5. Divide both sides by 2. We get x equals 5 over 2, or 2.5. So we know there's a value at 2.5. So let's find our y value. And to find that, all we need to do is substitute x equals 2.5 into our third equation we had up there. So that was y equals x minus 5. So we have 2.5 minus 5, which is negative 2.5. So what this means is we have our x, which is 2.5, and we'll have our y, which is 2.5. Sorry, negative 2.5. So those are our two values. Now the only thing we need to do is test if it is a minimum. So we want to differentiate our first derivative, and the first derivative we had was 2x minus 5. So our second derivative is going to be 2, and since this is greater than 0, we have a minimum, which is what we needed. All right, so the answer is our two numbers that we need that have a difference of 5 was 2.5 and negative 2.5. So as you can see with these type of problems, the goal is the same thing we've done for previous videos in this playlist. What you need to do is you find your equation first. If you've given it, that's great. Once you found your equation, what you need to do is then you find your first derivative, identify any stationary points, find your minimums or maximums depending on what the question is asking, and go from there.